Hey everyone, this is Scott from Octava Engineering, back with another how-to video. And this time we are going to run a final test module on actuators, particularly an Allen-Bradley MPAI actuator. And you can see I have the camera view set up here. So before we jump in to the software, just point out quickly the proper way to set up an actuator motor to perform the final run test. So as you can see here, we have this motor set up on the floor. So you're going to set up your actuator motor either on the floor or on a table long enough and clear of obstructions for the actuator shaft so that the actuator shaft can move freely. And in this case, because this shaft not only extends and retracts, but it also has circular motion, I have a C-clamp attached to the actuator shaft to hold it in position. So I'm only going to get linear motion as we go through the test as opposed to rotation. And that is just so the system, when it is verifying the inner and outer travel ranges, make sure that the revolution count is accurate as the actuator moves. So there you go. Make sure the shaft is clear of obstructions, either on a floor or long table. And if you have a rotating actuator shaft instead of just one that extends in and out, make sure that you have it secured in some way. Please don't use your hands. Use a C-clamp or a vice grip, something like that. Don't use your hands while the actuator is in motion. So that being said, we will set up the software for the test, and it is a final test module. So we'll go to Motor and Final Test. You can see my drop downs up here are already set for SICK hyperface with auto identify selected. And my drive is connected, judging by my status green light here. So for motor parameters, I'm going to select actuators. Enter the rated current of the motor, in this case 13.7 amps, torque 10 newton meters, 3000 RPMs with a 24 volt brake. Now over here in the run parameters, the grayed out analytics time is the number of test minutes that are going to be used to perform the final test. The runtime here does not use test minutes. That is free runtime in between the two analytics phases, so you can get the motor up to temperature and also listen for like bearing noise, any abnormal noise or abnormal vibration coming from the motor itself. For this demonstration, I'm going to leave it at 1 minute, but normally for a motor this size and an actuator this size, I would run it for probably around 15-20 minutes. Set my speed to 1000, and I'll leave my XL and D cell at 100. So once you have those filled out, click Configure Drive. And as with all of our run modules, the first thing we're going to do is click Clear Faults, just to make sure that the drive is not in a faulted state from maybe a previous test, something like that. And then we'll click Enable Access. And you may have heard it kick on there. This is kind of a noisy one. Unlike standard servos, there's an extra step before we can hit Start Collection and begin the test, and that is manually extending the actuator shaft to about midway between the inner and outermost travel limits here. So as you can see, this pop-up box is instructing you to use the jog buttons to kind of get that actuator shaft to center. It doesn't have to be perfect, just get it as close as you can. And once you acknowledge this and understand those instructions, you're going to click Close, and then use the jog buttons here to move the shaft. As you can see, mine is almost fully retracted right now, so I am going to click and hold on the jog forward button to extend the shaft out. And again, we're going to go about halfway. Right about there. So once I have my shaft to about the midway point, then I can go ahead and click start. And now the final test has begun. So the first step here is a calibration procedure. Not only is it verifying encoder movement based on my drop-downs and based on the programmed speed of the drive, but is also going to find the outermost and innermost travel range of the actuator. So as that actuator gets fully extended and it reaches the outer limit, the system will detect that and then begin moving in the opposite direction. All right, so there's the outer range, and now you can see it found the outer range and is now reverse direction to retract the shaft to find the innermost range. All right, and it looks like we're about to reach the inner travel limit. There we go. And so now that we've found the inner and outer travel ranges of the actuator, the software is now reprogramming to do a commutation check of the encoder to make sure the alignment's good. So now we're checking the encoder alignment. Of course, because this is a SICK hyperface encoder with a commutation offset programmed into it, we're looking for that calculated commutation value, not an actual electrical degree. All right, so it looks like we passed the first alignment check. And now, just like we do with a standard servo, we are simulating a load test on the stator. And we're doing that by pumping current into the different phases. So we can measure the current draw and the amplitude of each of the phases in the stator. That will be included on the final report as well. All right, and now before moving on to the first analytics phase, we're just retracting the shaft back into the innermost position. All right, and now we are in the first analytics phase. So again, Analytics 1 and Analytics 2 are the only parts of the final test that are going to use the test minutes. So as we pass that first test minute, you'll see the minutes in use bar light up here. And so now the system is checking each of the encoder signals. And if you have your O-scope connected to the Linea, then you can see those signals being analyzed in real time on your scope as it checks that signal. And the other big difference on an actuator final test compared to a standard servo final test is that we are reversing direction periodically in the analytics mode just to keep the actuator shaft from going in one direction for too long. All right, and we're inside of our 5th minute, so Analytics 1 should be finished rather shortly. All right, so first Analytics is complete. And now the software is verifying the innermost travel range before beginning the free run. All right, now we're in the free run range, or the free run mode, I should say. So again, normally this motor, it actually heats up pretty quickly, so I would normally set the free run time for about 20 minutes. Of course, here it's just 1 minute. But this is where you can listen for the bearing noise, listen for any kind of grinding or anything like that as far as the movement of the actuator is concerned. Feel for any abnormal vibration. But most importantly, we are getting the motor up to actual operating temperature so we can recheck those encoder signals at operating temperature and recheck the alignment after it's been running for some time. All right, so now that the free run portion is completed, we are re-verifying that innermost travel range. And the reason we do this several times throughout the test is just to make sure that we don't damage the actuator by trying to pull it in too far. All right, and now we're doing a second commutation check, second alignment check. This is important after the motor's been running for some time to make sure that if there's any kind of hardware malfunction in regards to the encoder position, that the alignment's still good. So if a screw wasn't tightened properly, if a coupler was broken, something like that, which would cause the physical movement of the encoder to shift, it would shift during that free run portion. So a second commutation check after the motor has been running is very important to make sure that the alignment is good. All right, so it looks like we passed the second alignment check, so our alignment is still good. And now we are on to the final analytics phase where the rest of those 12 test minutes are going to be used. And so again, we're checking all the encoder signals one more time, but now presumably the motor's been running and the motor is at actual operating temperature, not just at room temperature. All right, approaching the end of the second analytics phase. All right. So after the second analytics phase, the final test is now complete, and we have our report worksheet here. So you enter your customer name, the job ID, whatever number you use to internally track your work, who performed the test. And then again, for encoder ID and motor ID, we actually recommend using the serial number of the device as opposed to just the part number. All right, and once your fields are filled out, click Save and Show to generate the report. And then there is the final test report. So you can see overall percentage of the encoder in terms of scores, 95%. No out of bounds or critical faults occurred during the test. And we have verification that the alignment check, the commutation test is passed. Overall score condition, or overall encoder condition, is considered excellent. Then you got your summary, verification of the lock-in points for the alignment check, and then you can go through, check out the graphical data for each channel. Here's the graph for the phase amps. This one looks a little unique. And then you can also view the individual data points that were pulled for each channel to pull the graph. So yeah, that's it. That is how you perform a final test on the actuator itself. Thank you for watching, and as always, if you have any questions, please reach out to us at support@octavaengineering.com. Thank you.